Hi everyone. So today we'll be solving the problem number 2402, basically meeting rooms 2, right? So here let's see what the question states, right? So first, just give me a second here. Yeah, we have n rooms, right? We have n rooms 0 to n minus 1 we can consider, right? So index 0 based on the 0 index. So we have n rooms and the meetings of I equals start and end with the unique starts, right? And the meetings of I is equivalent to the start comma, and see here, this is nothing but start, this is nothing but the end. So again, this is nothing but the start, and same goes with the this one as well, right? So 0 start 10 and 1 start 5 and 2 start 7 and 3 start 4 end, right? So with the unique starts, each meeting uses the lowest numbered free room, right? So if none is free, it waits until the earliest room frees, right? And then uses that room for the same duration. Waiting meetings are served in the order of the original start times, right? So we have to remember these things. Now what we need to return, basically we have to return the room index that hosted the most meetings, right? In that case we have to go with the ties, basically when we have the ties, sorry, when we have the ties, so we have to go with the smallest index. That's what I wanted to say, man. So this is fine. So I hope the question part is completely clear. See, we have n equals to 2 and the meetings we have here, this one, right? So output is 0. Why output is 0? They have clearly mentioned here. At time 0 both the rooms are not being used, right? So we are not making use of any rooms, 2 rooms, basically n is 2 here, right? So the first meeting starts in the room 0. At time 1 only one room is not being used, right? So the meeting starts in the room 1, basically room 1, meeting starts at the room 1, right? At the time 1. See, at the time 2, basically both the rooms are being used, 1 and 2, right? So here the third meeting is delayed, right? At the time 3 both this one rooms are being used, the fourth meeting is delayed. For the fifth one, the meeting in room 1 finishes, basically, right? So the meeting in room 1 finishes, the third meeting starts in room 1 for the third period, 5 comma 10, this one, yeah, 5 comma 10, basically. At the time 10 the meetings in both room finish, and the fourth meeting starts in the room 0 for the first time, for the time period 10 comma 11. Both rooms 0 and 1 held 2 meetings, so we return 0 here in this case, right? Same goes with the example 2. They have explained it beautifully. You can just go ahead. So let's do one thing now. Let's discuss the approach followed by the complexities, and then let's write the code. First let's discuss the approach. Let's consider the same this one first example. As we have the idea on this, let's consider the same first example here, right? So first what we will do, we will sort the meetings by their start times, right? Starts are unique, so order is fixed here. They have strictly mentioned starts are unique in every example. See here, 0, 1, 2 and 3 all are unique numbers, right? So first what we'll do, we'll sort the meetings by their start time. Starts are unique, so order is fixed here in this case. So we will keep a min heap free. We will keep a min heap free of free room indices, right? So this is important, basically ordered by the end time, so then we will maintain a count for the meetings held per room. Count variable will be maintaining, that is held per room, basically, right? So this one I'm speaking of. This one you'll get to know when we write the code. Just remember this one, this is just the variable name, count variable for the meetings held per room, right? So this is fine. For each meeting in the start order, so what we will do, we will release all the busy rooms whose end time is less than or equal to meeting dot start. End time, what we will do, we will release all the busy rooms whose end time is less than or equal to meetings dot start, basically, right? So this is fine. Back into the free. If free is not empty, then we will assign the smallest room index immediately and push start plus duration comma room into the busy. Else what we will do, we'll pop the earliest busy room, schedule this meeting to start at the room's end time, right? So new end equals earliest end plus duration, and we will push the updated new end comma root back to busy, right? So this is fine, I believe. Now let's we have discussed this one theoretical part. Let's try to implement the same thing for the example one so that we understand this one clearly. So for the example one, so we have to go with the first time 0 we have. See here 0 1 2 3 start we have, right? So at time t equals 0, what we will do, free will be basically 0 comma 1, right? 0 comma 1, free will be 0 comma 1. So we will assign room 0 to 0 comma 10, this one, room 0 to 0 comma 10, right? Count of 0 will be 1 and busy will be 10 comma 0 here in this case again. So at t equals 0, free will be 0 comma 1 and we will assign the room 0 to 0 comma 10 and count of 0 will be 1 and busy equals 10 comma 0. Same we'll be doing with the time 1, time 2, time 3, time 5, right? So time 1, time 2, time 3 and time 5, right? So also time 5 and time 10, sorry, time 10 also we have to consider, right? So here in this case for the time 1 we have free equals basically 1 here in this case, free equals 1. So we will assign room 1 to 1 comma 5, count 1 becomes 1, busy will be 5 comma 1 and 10 comma 0 here in this case. What about time 2? Time 2 we have this one, free is empty, so meeting 2 comma 7 is delayed. So in the third step meeting 2 comma 7 is delayed here, 2 comma 7 is delayed because we have free empty, right? So this one meeting 2 comma 7 is delayed, third step. So I'll just write D here just to show that meeting 2 comma 7 is delayed. At time t equals 3 it is still delayed, at time t equals 3 it is still delayed, right? So it is still delayed for the time 3. This is fourth step. When we consider time t equals 5, here as we had discussed earlier, 5 comma 1 is freed here, right? So 5 comma 1 is freed, free is nothing but 1 here, free is nothing but 1 here, this is fine, free is nothing but 1. Next delayed meeting would be here, in this case it would be 2 comma 7, it would be 2 comma 7, gets room 1 and runs 5 comma 10, right? So this one 2 comma 7 gets the room 1 and runs 5 comma 10. So this one gets room 1, basically this one I have already mentioned, this one here, right? So this is fine and runs 5 comma 10. Counts of 1 here, so counts of 1 becomes here, this time it becomes 2, counts of 1 becomes 2 basically, right? So now we are left with a t equals 10, right? So the last one at t equals 10, so this is for this one t equals 0, this is for t equals 1, this is for t equals 2, this is for t equals 3, only delayed part. So this is for t equals 10 basically, this is for t equals 10. So basically sorry, we have to go with t equals 10, right? So this is for t equals 5 basically, t equals 10, both at t equals 10. So let me write it over here, t equals 10, what happens, both the rooms are free here, both the rooms are free. Last delayed was this one 3 comma 4, last delayed was 3 comma 4, nothing but the last one here, the last one here, this one, right? This one basically, the last delayed was 3 comma 4, which starts at t equals 10 in the smallest this one free room 0, run set basically, this runs at 10 comma 11, this runs at 10 comma 11. Now again the count of 1 was 2, so this time count of 0 will be 2, count of 0 will be 2, right? So the final step is the counts equals 2 comma 2, right? So counts equals here, see this one 2 comma 2, right? So count equals 2 comma 2. So this one, as I had explained earlier in the question itself, I had explained whenever there is a tie we have to return 0. So we have got a tie here, right? Counts equals 2 comma 2. So this one 2 we got, count of 0, count of 1 also we have got 2 here. So counts we have 2 comma 2, whenever there is a tie then we have to return 0 in that case, right? So we will return 0. So the output that we got here is 0, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So our approach works absolutely correct here in this case, right? As we are completely familiar with the approach, let's do one thing, let's quickly discuss the complexities part, right? So what would be the time complexity here? The time complexity would lead to big O of this one, m log m plus we have to go with big of m log n as well. I'll explain why, right? So this is fine. So this is the time complexity here we'll be going with. So why it is big of m log m plus big of m log n here? So m is nothing but the meeting start length, so we will be sorting by start, right? Basically it takes big of m log m, and each meeting does big of n logarithmic priority queue operations, right? PQ operations or priority queue operations. So overall time complexity would lead to big of m log m plus big of this one, what do we call m log n, right? So this is fine, I believe, easy. Now let's move on with the space complexity part here. What would be the space complexity here? The space complexity would lead to big of n. So here why it is big of n? We are going with the extra, nothing but free plus busy heaps, and also the count array, right? So I mentioned count array somewhere, that is nothing but this one, count array, right? So I mentioned this one earlier during the approach. So this one will be making use of extra free plus busy heaps and count array, and sorting also will be doing, but it is in place on the input. So overall space complexity would lead to big of n here. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m log m plus big of m log n and big of n respectively, right? So basically so this is it for the complexities part. As we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. So this solution will be huge. Basically let's go step by step. First what we'll be doing, so we will be sorting the meetings by the start time in the ascending order, so we can process this one in the original start order, right? So let's go step by step accordingly with the approach, right? So just give me a second here, 1 second, let me copy this one, man, so I just don't have to type the meetings everywhere. So I'll just go with arrays dot sort. So this one will be meetings comma a comma b here. So we are sorting here, right? So this one has to be integer dot compare. So this is also fine, a of 0 comma b of 0. This is fine, I believe. So the next step here would be let's go with the minimum heap of the free room indices. So this always gives the smallest numbered free room. So let me go with priority queue. So this is fine. Let me pass, so this is of the type integer, right? So this is fine. Let me go with the variable name free. So this one will be new. Let me copy the priority queue. I don't want to type this one. This is fine, new priority queue. Then syntax, let me complete this one. This is fine. Now initially all the rooms are free, right? So let me go with the iteration here. So this one will be int I equals 0, I less than n. Let me go with a I plus plus. Initially all the rooms are free, right? So this one will be free dot offer of, we have to pass I, sorry, I, what did I do, man? Yep, this is fine. Now so min heap of the busy rooms, we have to consider min heap of the busy rooms in which each entry is long, basically, right? So we'll be going with the type long, basically n time and the room index. Also we will be going with the ordered by n time ascending, right? So we'll be going with the ascending order, basically tiebreaker by the room index, that's also ascending, basically, right? So let's try to implement the same thing in the form of code. So this one will be priority, I had copied priority queue, I believe. So just give me a second here, let me paste the priority queue here. So as I have said, we'll be making use of the long here, long we have to give within the array, right? So this is fine. So let me go with busy new. So this one is priority queue. This is fine, new comparator. So this one will be long. Yep, so this is fine. Yep, let me open this one. So I'll just go with public int. So let me go with compare here. So this one will be long a long b. This is fine. So within the compare, so method what will be doing, so we have to go with the earlier end first, right? So let me write the simple if condition here. If a of 0, this one, if it is not equal to b of 0, then what we need to return here, return long dot compare here. So this one a of 0, this is fine, comma b of 0, this is also fine, earlier end first, so this is fine. So the next part would be, let's return something, meaning we have to go with a smaller room index, right? So I'll just return here, this one will be long dot compare. So this one will be a of 1 comma b of 1. So this is fine, the smaller room index basically, this is fine. Let me come out of this one entirely so that we can move on with the further things. So we have to go with the count of the meetings held per the room, right? So I'll be going with the basically count variable. Let me initialize this one to the count of size, and basically this is fine. Now let's process each meeting by its original start time. So let's go with a simple for loop here. So this one will be int empty, so this is fine, of meetings, right? So this is fine, man. So within the for loop, first we have to go with the original start time. So I'll just go with start. Let me initialize this one to the, or let me assign this one to the empty meeting of 0. Let me go with end. So this one meeting of 1, and the final one is we have to go with the meeting duration as well. So I'll just go with long. So this one will be duration. So let me assign this one to the end minus start. So this is fine, end minus start. So this is fine, right? Now let's we have to free any rooms that have finished by the current meeting start time. So let's write the simple while loop here. So while, so see here, so this one, don't get confused here, while not of busy, let me make use of is empty here. This is fine. Yep. And so this one will be busy dot, let me make use of the peak, right? So peak operation, this is fine. Let me pass 0 if it is less than or equal to start. So this is fine, man. Within the while loop, what shall we do? So let's remove the earliest finished room, and also let's push its index back to the free rooms, right? So I'll just go with a long here. So this one will be freed, this one will be busy dot poll, this is fine. The next one would be free dot offer, this is fine, of int this one int is fine. This one will be freed of 1. Yep, this is fine, man. Now we have successfully pushed its index back to the free rooms, right? So let me come out of this one entirely. Now let's write the simple if condition. Oh, the code is really huge, man. Right, code, this one, if there is a free room, then we have to assign the smallest indexed this one free room immediately, right? So see, let's write the simple if condition first here. So not of free is empty if the rooms are, if there is a free room we are considering, right? So this is fine. So within the if condition, then we have to assign the assign the smallest indexed free room immediately, right? So let me consider room here and assign this one to the free, and let me make use of the poll operation, right? So this is fine. We are just picking the smallest free room here, man. Don't get confused. See here, next part is we have to increment its meeting count. So I'll just go with the count of room. So let me increment this one. This is fine. The next part would be, so we have to go with a meeting that runs from start to the start plus duration. So this one will be long new end equals start plus, so this one will be duration. right? So this is fine, I believe. The next part would be we have to mark this particular room as busy until new end. So this one will be busy dot offer new long, this is fine. This one will be new end comma room. So this is fine. Yep, this is fine. Else what we will do, else what we have to do, if there are no rooms no free rooms left, then we have to wait for the earliest room to become available. So that one we have to implement or articulate in the form of code. First let's do one thing, let's go with the earliest finishing busy room, right? So I'll just go with long here, this is fine. I'll just go with earliest, so let me assign this one to busy dot poll, right? So let's make use of the poll operation here. The next step would be we have to go with the time when that particular rooms becomes free, right? So let's go with a available time variable name here. This would be suitable here, right? Available time, let me assign this one to the earliest of 0. This is fine. This is time when that room becomes free. Then we have to consider its index as well. So this one will be int room equals, so let me go with the int here. So I'll just go with the earliest of 1. This is fine. So next let's do one thing, let's go with a delayed meeting that goes to that particular room, right? So this is nothing but the why we are writing this one. So we are just will be incrementing count of room basically. See, let me write this one first and then explain this one. This would be correct. Basically this delayed meeting goes to that particular room, right? So this is fine now, right? Simple to understand. Now that meeting basically it starts at the available time and runs for the particular duration, right? So now how can we write that one in the form of code? So this one again it will be of the type long, so I'll just consider new end equals, so let me copy this one available time. So this one I'll just assign this one to the available time plus duration. This is fine. Finally we have to put the room back as busy until the new end. So this one will be busy dot offer, so this one will be new long, this is fine. Finally what we'll do, new end comma room, so this one will be new end comma room, right? So this is fine. Yep, so we have just put the room back as busy until the new end. This is fine, man. So next let me come out of this one entirely. So now what we need to do, we have to find the room with the maximum meetings, right? So this if it is a tie, then we have to go with the smallest index, right? So this one, let me assign the answer to 0. This is fine. Let me go with for loop. So this one will be int I equals 1, I less than n, so this one will be I plus plus. So within the for loop, so let me go with if count of I, if it is greater than count of answer here in this case, so then I'll just assign this one to the so sorry, did I keep L? So this one has to be I. This is fine, typo. So this is fine. The final step would be, all we have to do is we have to return the index of the most booked room. So that's what they have asked in the question, which will be stored in the answer variable or the result variable ans, right? So let me return here answer, this one ans, right? So this is fine. We are done with the coding part. Let me format the code once and let me hit the run button. I hope this works, man, for God's sake. Let's see. Oh, we have error. So this what happened here? If a of 0, just give me a second here, not equal to, oh, this one we have to go with capital L. Yep, so that is the reason we are getting error here. This is fine. Let me run this one again. Oh, we have one error left. So this is in the line number 3. What error we have? Arrays.sort meeting. So integer dot compare. So again the same mistake, man. This has to be capital I. Let me run. Let me hit the run button. So I hope this works now. Yep. The sample test cases are getting passed. So let me hit the submit button. I hope this works for all the test cases. Let's see. Yep, all the test cases are getting passed. Means the code works absolutely correct. Whatever the code that we have written works absolutely correct for all the test cases, right? Yep. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.